Why on earth have we had the network for so long and yet we can't predict when something's going to go wrong? Surely the AI should help me know, rather than, okay, it's broken, now do something. It can't predict that there's a problem.
We keep saying it's always the beginning. I think that in a year we'll keep saying this is still the beginning, because when it's almost endless, there are so many paths to take that are so promising.
Yeah, so I've heard this statement, you won't be replaced by AI, you'll be replaced by someone who uses AI.
Go outside of the comfort zone and look at maybe you can start with what you know already, and then see how you can start using machine learning AI with your area of expertise. When you have thousands of switches, wouldn't you want an agent to check the configuration of all of the switches, as opposed to leaving a hole somewhere that will be bad at some point?
Everyone, it's David Bombal coming to you from Cisco Live, back with JP. JP, welcome.
Thank you very much, David. Very happy to be with you, as always.
JP, we spoke about a year ago at Cisco Live in Amsterdam, like we are today. Lots have happened since then, right?
Oh, yeah. So it was only a year ago, but when you look at what happened in the world of AI, what a year we had. It's not so easy, by the way, to come up with a summary of what happened, but I believe that what happened with generative AI especially was really the long-awaited revolution we've been waiting for quite some time.
Yeah, of course. Yeah. I mean, what is generative AI versus AI? Because AI is just like buzzword.
Yeah, it is. Absolutely. And, you know, it's an interesting question, because I've got this question all the time. What is ML versus AI versus generative AI? And what I tend to say to people is, don't fall into the trap of trying to really come up with a taxonomy. Machine learning is probably the most used form of artificial intelligence.
Okay.
And generative AI is, you know, really about producing things, if you will. So if you look at machine learning, you probably know about classification, regression, and this type of algorithm. When you look at generative AI, what we do is that you give as input some text, for example, and the model is going to produce some text. If you look at generative AI for videos, for images, for example, and I'm sure you know about DALL-E and Midjourney. That's exactly what this is about. This is generative AI as well. What people sometimes don't know is if you open the box, generative AI is also relying mostly on what we've been using for a long time, you know, like transformers. Transformers is a kind of neural networks that have been invented in 2017-18 by Google. And this is just a use of this kind of architecture that changed a lot of things. But it's not just that. There are many, many other components. So this is what generative AI is about. So now, why is it that all of a sudden we started to see such a big adoption? I do believe that there are many reasons for that. The first one is, of course, Chat GPT, and everybody started to use it. And I don't know for you, David, but sometimes you are blown away by the results.
Exactly, yeah.
And sometimes you look and you say, oh, that's not so smart. And there is a good reason for that. But as you probably know, Chat GPT is the most successful applications we've seen in almost 30 years now, because of the adoption, with hundreds of millions of users using it. Which is a bit surprising, obviously. Now, if you want to compare AI, machine learning and generative AI, sometimes people say, well, does that mean that generative AI is going to replace machine learning, for example? That's not at all the case. We believe that transformers, for example, at the heart of generative AI, could be used for a plethora of use cases. I'm sure we're going to talk about that as well together. But for specific issues, at least as of now, like classification. So suppose you want to use machine learning to detect whether a piece of software has been compromised, you know, infected by a malware, and you want to do classification, then the classic machine learning types of algorithm are absolutely really, really good for that.
Okay.
And you don't want to use generative AI for this kind of issues. Even for time series prediction, we start to see people who say, well, maybe we can use generative AI algorithm to do that. But as of now, by far, for time series forecasting, machine learning, the classic machine learning is really good. What is really interesting to me, though, is the bar to entry, if you will.
Yeah, you mean when you say bar to entry, like how to get started, right?
Yeah, exactly.
Because I think that's, AI is hot and everyone's being told, and I mean, I'm telling people, you know, you need to learn AI, but like you've been doing this for how many years?
Yeah, 12 years. 12 years. So here is what I would say, which I believe is a very interesting phenomena, is if you look at the time it takes to productize, have a really high quality kind of architecture and software, it used to take, I would say, months with classic machine learning. So let's go back to the example we talked about, classification, right?
Like
so,
malware versus normal traffic, right?
Exactly.
Yeah.
We can take that one as an example. What you would have done before, and you're still doing, is to say, okay, I need first of all to find a data set. Once you have a data set, you are going to work on the quality of the data. And what sometimes people say garbage in, garbage out, these sort of things. And what you would do is probably to have some data scientists to help you with that, look at some signals in the data, and then you would have some machine learning engineers. And their job would be to say, okay, I'm going to train some models. I will define what is a good metric to determine what is a good, efficacy for the system. And this is a very important point. We'll go back to that for generative AI in a moment. Once you have your metric, you start to train the model. Then you look at the efficacy and you can tell if you are doing a good job or bad job. And if it's not good enough, you tune the model, you retrain it with higher quality data and so on and so forth. So before, I would say that it would have taken, weeks or months to get there. These days, if you want to do, translation of a document, or you want to do performance analysis of a network, it will probably take a few days instead of, weeks or months. The problem is, though, that because of the complexity of the architecture and the degree of dimensions, I will go back to that in a minute, it's very easy to start. But then you get, from time to time, you look at the result. And as I said before, you could be blown away and say, wow, the system is so smart. And in other cases, you would look and say, wow, this is doing weird stuff.
Yeah,
you see what I mean?
Chat GPT stuff is sometimes interesting.
That's right.
Yeah.
And so this is known as hallucinations.
Yeah, exactly.
And the problem is that how do you control hallucinations? So what I believe is going to be a major challenge is really the reliability of the system.
Yep.
And if you want to play with it, that's just fine, right? You can afford to have sometimes very weird outcomes. But if you want to make it a product, now you need to be able to say, okay, what is the right metric for my system? And how can I reduce the risk of hallucinations and issues? And then it takes way more time to get there. And that's why the product development cycle, is going to look very different than with classic machine learning, where it used to be fairly deterministic with very well-known steps, if you will. But if you look at generative AI now, because of the complexity and as I said, the number of things you can tune, and sometimes the lack of reliability, yes, I would say at least for now, it may take much more time to come up with the quality that you require.
Yeah, because you work for Cisco. Cisco traditionally is a networking company.
Yes.
I would worry letting AI do stuff on my network without me getting involved.
Yeah. So, that's why the way I love to position generative AI in the context of networking is I don't think we're ready to close the loop and let the system do whatever it wants. But it could be a co-pilot or an assistant, if you will. And if it can solve 80% of your problems, and what used to take, weeks, for example, now it takes 1 day or something like that. No, not even 1 day, a few hours.
Yeah.
Then you can judge and say, well, that sounds like good enough. I can check the quality of the outcome as well with the human in the loop. It is not to say that, down the road, the system will not be able to close the loop by itself, but we're not there yet, if you will. So that's why when you look at it as an assistant, I think that opens so many doors. Maybe I can give you some examples.
That'd be great, yeah.
All right. So let's take an example of performance analysis.
Yes.
And we all know that from time to time, you look at your UI and you don't have exactly the metric you're looking for. Yeah. What it would take you to do today is basically to say, okay, suppose that I want to look at the correlation between the packet loss and the time to complete a job, when you are trying to do, AI workload training, for example.
Yeah.
What you would have to do today is basically to look at the API to collect a bunch of data. You would probably call your best data scientist a friend, and you would say, could you load basically all of these variables, make sure that they are correctly documented, we understand what this is about. And then you would probably take a pandas or whatever and start to do the math and come back to you and say, hey, David, this is a correlation between these two. Well, I think it would be kind of cool to ask to a generative AI model to do the job for you.
Yeah.
And that's something that is absolutely doable. We've been working on it for several months, I would say. And I'm not going to announce anything today, but very soon. And so if you look at performance analysis or trend, the number of times, IT leaders, they say, do you see a trend in the growth of traffic of that kind between these two sites? And what you need to do is to look at the raw data, start to filter, do some math. Well, that's something an AI agent can do for you within a few seconds. And I think this is a very promising area. I'm even more excited about troubleshooting, but we'll go back to that whenever you want in this interview.
Something I've heard from a lot of people is, why on earth have we had the network for so long and yet we can't predict when something's going to go wrong? Surely the AI should help me know, rather than, okay, it's broken, now do something. It can't predict that there's a problem?
Yes. So as you know, David, we worked on a predictive internet for years, and we use classic machine learning, to do that. The main difficulty, obviously, is there's no mystery, right? You need to give a signal to the engine so that the engine says, when I see that signal, it's basically a sign that something bad is going to happen.
Yeah.
So, and, there are cases where you don't have such a signal, or maybe you have it a few milliseconds before. If you look at the fiber cut.
Yeah, exactly.
You do have a signal, but, just a few.
It's too late, right?
Yeah, it's way too late. Sometimes it's very fuzzy. There's a little bit of an early sign if you look at the power outage. And so for these kind of issues, they're not predictable or hardly predictable. If you look at congestion across the internet, well, especially if you have seasonal effect, then you can start learning this kind of signal and then become predictive. And that's what we did with predictive internet. And so if you look at generative AI now in that context, I'm not sure that generative AI is, as of now, the best tool in order to become predictive about something happening. But it could become an amazing tool if you want to do troubleshooting.
Okay.
And we know troubleshooting is awfully complex.
Yeah.
In some cases, the best guys in the NOC, they would say, okay, this guy complains about this issue. Immediately you're going to check a few things, right? You have your SCP and you check and you say, yes, I know, this is probably because of a Wi-Fi issue or congestion over the internet, something like that. Now, what I would like to do now is to start using generative AI systems that might be capable of reasoning and learn how to solve very complex tasks. And I think this is extremely promising area. And this is really, I believe, first the signs of intelligence when you start to figure out what is the best reasoning path that will lead you, to the root cause of a problem, if you will. So this is another example where I believe this is going to change a lot of things for networking. So performance analysis, troubleshooting, natural language as well. Some people, they had some hard time remembering the CLI commands and all that kind of stuff. What if you could, interact with a system, with a network, with natural language, and you would have a chat with some history as well, right? So you want the system to remember past discussions, for example, and find a way to map your question with existing commands, reformulate the question, come back with an answer. That would be super cool as well.
So two things. It sounds like the interface will move. It moved from CLI to perhaps GUI. Perhaps we've got a chat interface. But on the back of that, I want you to answer about jobs, right? Because that's the worry a lot of people have.
Yeah, I understand this is a worry. What I tend to say now, to be honest, is that I don't think that AI is going to replace subject matter expert. But I also believe that being an expert in the field of networking will no longer be sufficient.
Okay.
That's a given to me. And you may answer, but why? Is it because at the end of the day, why not using a tool that can save you so much time? And if you don't, others, people will do that for you.
Yeah, so I've heard this statement, you won't be replaced by AI, you'll be replaced by someone who uses AI. You think that's true, right?
I think that's true, absolutely. because it's so tempting.
Yeah.
And again, at Cisco, when you look at how to use, I'm someone extremely pragmatic. I've been doing AI for a long time.
Yeah.
But I never believed of an approach where you would start with a technology. Actually, I believe that the best way to kill technology is to be passionate about technology, because you tend to forget the use case.
Yeah.
Now, I've never seen a technology that can have so many implications and use cases. And I came up with three. I just shared with you three use cases. And so wouldn't you expect people to start using tools if they can save a ton of time and focus on interesting stuff, very interesting stuff? So the machine will never be able to design a complex networks and these sort of things, but it could save you a ton of time and do performance analysis for you, troubleshooting, all that kind of stuff. So that's a given. I don't think network engineers can afford not to learn a bit of machine learning AI in the future.
Okay, so you mentioned two things there. Like earlier, you said the barrier to entry is lowered.
Yes.
And you said we need to learn that. So what do I do?
That's a very, very interesting question. The barrier to entry is lowered, absolutely. But it doesn't mean that you don't want to understand the way the technology works, if you will. So as a practitioner, you don't need to have a PhD in mathematics to start using machine learning.
That's the worry, right?
Yeah, that's the worry, but it's not the case at all.
Okay.
When you design a product, you need to understand how the technology works so that you know the limitations, for example. You know when it is ready, when it is not ready. But not using these kind of tools for networking, and that's true for healthcare, it's true for education, it's true for advertisement. We do see, pretty much all of the areas being disrupted as we speak. I'm talking to many, many customers in multiple domains, like retail, healthcare, industries, and I haven't seen a single one that is not looking at the impact of AI and generative AI on their business. And yes, you could start to ignore it and say, well, okay, this is just a buzzword.
It's too late.
I think it's too late for good. That's really what I believe, to be honest. I mean, there's a lot of things. Now, you need to understand also the limitation of a product. Back to your point. If you use it as a tool that is kind of a black box, how do you know when you can trust the system, you cannot trust the system? So you need to understand a bit how the technology works as a practitioner and start using it. It's fun, right?
Yeah, exactly.
It's just fun. And we've seen so many technologies in the past that have been disruptive, indeed. But at the end of the day, we just adapted and then we moved to the next phase.
When I interviewed DJ about the firewalls, he mentioned three places. He said prompt engineering is a place that you could start at, but then you've got APIs, and then you've got someone like yourself, perhaps PhD in math or deep data science knowledge. You agree with that? Like there's opportunities in those three places?
Yeah, I think that, what I would say, first of all, is as someone who is building products, and this is the first time we see so many dimensions. I mentioned that a few times. What do I mean by that? Well, the way you interact with generative AI today as a user, you just prompt the system, right?
Yep.
You ask your question. You may give some feedback, first of all, a bit of background and say, you're a nice guy and I want you to write a poem for my wife, whatever.
Yeah.
I'm not sure I would use that for that, by the way, but it's a different topic, right?
Yeah, that is dangerous, yes.
Yeah, it could be very dangerous. But anyway, so what you see from a system is basically only the prompt, which is your only way to interact with the system and influence the system. When you build such a system, what you find is that you have multiple blocks. So let me tell you a bit more about that. So for example, if you wanted to build a product based on generative AI for networking, you would have what you call an agent. And the role of an agent is just to do different kind of tasks. And you would ask a question to the agent, and the agent could do a lot of things. So it could tap into some APIs, as you mentioned before. And there are many, many APIs that we have at Cisco and everywhere in the world. You can retrieve a lot of information. Then you need to have a memory. And the memory is sometimes known as the knowledge vector. And what you do, you store in a database, you store with what we call embeddings, which is a kind of, a highly dimensional space. You store a lot of information. So for example, you can store Wi-Fi documentations, recipes, and all these things. And then what you do is that You receive the initial question, you will retrieve some local memory, you build your prompt, and you ask the question now to a large language model, and you say, here's the task that I need to solve. I'm going to give you some information that I retrieved from my knowledge database, and let me know what to do. And so the LLM would say, okay, I want you to do this first task. It could write some code for you, and the code, you could use it to retrieve information from the API. Now, the art and the science of retrieving some information is going to have a huge influence on the ability of the system to accomplish the task. This is called as a RAG, retrieval augmentation generation. And now when you design the system, you say, wait a minute, so I need to understand the type of embeddings to use to store my data. I need to understand the best strategy to retrieve some information. I need to understand what is the best strategy for prompting, as you mentioned before. And now you have the whole world of large language models. So you can go with very big one, like GPT-4, 3.5 Turbo. You can go with small ones, like 5 from Microsoft, Orca 2. And maybe, it will not be one, but many models specialized in different areas.
Okay.
And then you have the agent that is executing the task. You need to clean up a bit the API. You see the level of complexity?
Yeah, it's getting rough, yeah.
Absolutely. So that's why I was saying that you could start within a few days with something a bit random. You do a bit of prompting. This is probably what you would do as a user.
Yeah.
But if you really want to rely on such a system to troubleshoot your network and hear that, you want something that is way have and you can play with all of these parameters. Not as a user, obviously, but as a product designer, this is what we need to do to have a very efficient system, if you will.
I mean, from the jobs point of view, I think people are worried that much more will be done with fewer people. But you talking about products, there's also an opportunity for people to create products.
Of course. And I also believe that, if you look at the teams troubleshooting operating networks, they are usually absolutely overloaded. Yes. And they have the same recurring questions, such as, I've got some issues in terms of QE for my application. That must be the network. And so you troubleshoot your network, you go back. And guess what happened the day after? You do it again. So if instead of doing that, you can automate the job of finding the most common root cases, maybe, root causes, you could start doing more interesting stuff and look at how to fine tune the system. So I'll give you another example. When you have thousands of switches, wouldn't you want an agent to check the configuration of all of the switches as opposed to leaving a hole somewhere that will be bad at some point? And you could come up with many metrics to really understand what's going on. And I cannot resist from saying another thing, which is about the layer 7, right? You've been in the field for as long as, maybe not as long as
a long time, yeah.
For some time, let's put it this way.
Yeah, we've about 2.5 years, you and I.
Exactly. Now, we love a layer 3, but at some point it might be good as well to do a little bit of layer violation. I said it on purpose because this dogma about layer violation, which I think is completely outdated. It was very useful to scale the internet, but now we are at a point when we need to understand cross layers. How would you do that today when you are a network engineer? Well, it's extremely complicated because you need to look at all of the metrics at the layer 7, do correlation with the layer 3, layer 4, and so on and so forth. That's where machine learning can help you as well. So it will never replace you, but it's going to be your best friend. That's really what I believe. And to be honest, that's something very close to my heart as well, which is sometimes people say, is it real ML? Is it real AI? But come on, it doesn't make any sense.
No.
You don't care whether it's called ML or AI. Does it make the job? And sometimes a very simple statistical model is doing an amazing job for you. But instead of doing that manually, you could rely now on some algorithm to do it for you, and you would be the brain controlling this agent. That's really what I believe.
I just think, people have been around for a long time. It's sometimes difficult to change.
Very difficult.
But if you don't change, someone, like we said, who's younger or more passionate is going to use this. And
of course.
You've got no choice. You've got to do it.
You have to do it. And in some cases, if I may share, I did a lot of routing for years and years. And of course, when you've done a lot of routing, you love routing.
Yeah.
But at some point, it may be, I wouldn't say a solved problem, because there are still many things to do, but it's time to change.
Yeah.
It's mature, absolutely mature. And at some point you need to move and say, okay, is there something else to do?
Yeah.
I was surprised, David, to see when I worked on the quality of experience, how little people know about what makes a good experience in terms of voice and video. Even when you go and talk to networking people and you say, what makes, they look at you and say, the delay should be below 150 milliseconds and whatever. Of course not. It's a rule of thumb, but do they really understand? Well, for that, you need to have, new tools.
Yeah.
And AI is a tool that will help you understand what's going on. So it will not replace you, but you alone, with your networking, expertise, it is not going to be sufficient to move to the next step and do more interesting stuff. That's really what I believe. It's an opportunity.
JB, challenges in AI and opportunities, I think are something a lot of people will be interested in.
Yeah. So, the one thing that I would say is the first thing to do is to resist from making, any predictions, because
you're going to be wrong. Yeah.
Absolutely. And this field has been moving so fast that it is really, really hard to keep up with the pace of innovation. And what I would say, to be honest, is that it could be a challenge as well, because the pace of innovation with also open innovation is so, it is going so fast that when you build a product, you need to know where to stop when it is mature enough, instead of waiting for the next technology to come. So let's talk a little bit about the challenges. Because as an engineer, as excited I am by this field, you also need to be very, very conscious of the limitations as well, because there are many limitations. So the first thing that I would say to people is, first of all, you need to come up with a good metric for assessing the efficacy of your system. And I wrote a blog a few weeks ago about that, because for some reason, people fell in love with these big dashboards, and they show a lot of large language models. And, there are many tests like human eval, for example, also mathematics and translation. And every week, they go and say, this new model is now better than the previous model. Okay, whatever. But when you build your own product to solve an issue, like, we talked about troubleshooting, which metric are you going to use? None of them can be used for your issue, right? And this is what I would say. I say, you need to start with defining the task you're trying to solve and how you are going to assess the efficacy of a system. So the first challenge is not related to the technology, but the methodology that you have to develop your own product, and know when you reach, a good enough level for the system. There are many other challenges. So if you look at generative AI, the first one that I mentioned at the beginning is reliability. We need to make sure that we can, understand when the system is going to hallucinate, or maybe stop the system before it does hallucinate.
Yeah, to worry the hallucinations.
Yeah. And my team and I, we are working very, very heavily on that kind of approach. And I see a lot of very interesting areas, and technologies to help with reliability, but it's still a challenge. The cost may be a challenge as well, because you mentioned about prompting. Could you afford to go with, very, very big model, and you need to burn a lot of tokens, tokens? Or maybe you may want to go back to a small model that is almost as good as the big one. So there are trade-offs to make, if you will. So these kind of challenges are real, but at the same time, I think this is a matter of time before we can solve these issues. And considering the pace at which, it has been evolving, it will not take long before we can solve. There will always be a long tail of small issues that are very hard to tackle. What are the most promising areas? It's a tough one to answer, but I'm going to try anyway. So first of all, hardware. When you look at the cost per flops, I would say, is going like crazy. If you look at GPUs now, TPUs, and there are many AI accelerators, this is, of course, it keeps going. And I don't know if you heard of a bitter lesson, but some people believe that it's more of a matter of compute, and so the more compute you throw, the more likely you're going to get the best outcome, if you will. So we will continue to require more compute, and the compute is definitely going to be a very interesting one. I believe that at some point, cost is going to be an issue. So I don't know if you've heard of neuromorphic computing, but
No, tell us. No,
all
tell
right.
us.
So the neuromorphic computing has been there for a long time. And the idea is to come up with architecture that would sort of mimic the brain. I'm very cautious about that because when you say mimic the brain, but spikes, if you will, that are used in the brain. If you look at the brain, we're talking 86 billion neurons, 10 to the power of 14 billion connections, because synapses, and it takes 25 watt?
Yeah.
25 watt, which is unbelievable. So many people have been looking at how would basically the brain work so that we can be inspired. And I absolutely believe that we should be more inspired by Mother Nature in many ways. And so there are companies like Numenta and other companies now that are looking at algorithms that are basically inspired by the way the brain works when doing computation in the neurons, for example, like sparsity and things like that. So this is also very promising areas, and there are many more to come. Quality of the data.
Yeah.
Super interesting to see that sometimes you can have models that are equally good as very, very big models, although they are trained on a very limited data set, but the data set has got a textbook quality. This is the example of a 5 model from Microsoft. And some people believe of curriculum learning. In other words, you train the model with simple issues and then moderated, difficulty, and so on and so forth. And so as you increase the level of complexity, and at the end of the day, you look at these small models, and this is another promising area, which is we may not need to have huge models that are very expensive. And maybe at the end, we'll see that smaller models, more specialized, will be useful as well. And they will be in a, sort of a magic assembly of multiple components together. We still have a lot more to discover, obviously, but this is a fascinating... my son is at EPFL now, and I told him all the time, you're so lucky, buddy, because when I was at university, that was the beginning of the internet. Gosh, I don't want to think about that too much, but still, you're at the beginning of a new era with AI.
That's a great point. So if someone's young or someone's trying to move from another area to this is, I always say, ride the wave. This is like really a hot wave, and it's only the beginning. Or
we keep saying it's always the beginning. I think that in a year we'll keep saying this is still the beginning, because when it's almost endless, there are so many paths to take that are so promising. What is now a known fact, and I still can't believe that some people still say, "Oh, it's a buzzword."
Yes.
So yes, there will be some setbacks. That's for sure. There will be disappointments. That's for sure as well. But it is there to stay. That's absolutely given. There are many companies investing billions of dollars. At Cisco, we absolutely believe in AI and generative AI as well. So there won't be any. I think this is here to stay, and we'll see more and more use of AI, generative AI in the future. That's absolutely given. The advice that I would give to younger people is don't try to over-specialize too soon. Think about the basic stuff like computer science, statistics, math as well. This is very important. And maybe at the end of the day, what will be the most promising is to be an expert in one area, like healthcare, for example, but be a very strong practitioner of ML/AI. That's what I believe the future lies. And that's going to open so many areas. I don't think you can be only an expert in healthcare or networking without knowing about AI, but conversely, you may not want to be just an AI researcher. We will need people like that background, but having dual kind of, expertise is super exciting, super promising.
So it's not too late, right?
Oh, it's far from being too late. I mean, but don't wait too much. I mean, because it's such an opportunity. Don't see it as a threat. Just start simple. There's so much content you can find to get educated about that at every age. You can absolutely do that. I think I don't even understand why people don't do that all day long, because it's an opportunity.
I also think, if anyone wants any kind of way to be convinced, look at the salaries and the opportunities, right?
Absolutely. And as I said, it used to take a long time to come up with this kind of AI product. Actually, on my website, I try to come up with a lot of videos and white papers to explain what the journey at Cisco has been. It has been an amazing journey, but we're going to see way more because it does accelerate. Why not? Just do it.
JP, I really want to thank you for sharing and inspiring people. And you're talking to your son, you're talking to people who perhaps are the same age or trying to transition into like something that's really hot and change their lives.
Yeah, David, this is a nice way to conclude the talk. I love that because, you don't need to start your studies at university to look at AI and what you can do with that. I think at any age, sometimes I have people who say, you're so lucky, you worked on IoT, MPLS, and so many things like that. And I kept saying, well, you think someone grab me and say, oh, would you want to do that? No, you need to move a bit.
Yeah.
So go outside of the comfort zone and look at maybe you can start with what you know already and then see how you can start using machine learning AI with your area of expertise. And you're going to find this as a super fun journey. And you're going to have a lot of fun. If you don't have fun, call me and then we will talk.
I'll put JP's details below. No, you can't phone him, but they can connect on social media, right?
Thank you so much, David. You are one of the best interviewers. I hope we'll stay in touch for a long time.
Look forward to it, JP. Thanks so much.
Likewise.
Appreciate it.
Thank you.